Alright, so welcome back to the OneClass channel. Again, my name is Joey. I'm going to be your math teacher for this session. So what we're doing here as OneClass, what we're doing is we are going through a series of verifying some frequently asked problems in both mathematics, chemistry, economics, and just common subjects in both the high school level as well as in the university and college level. And what we're doing specifically today is we're going to focus on some high school level math questions. So if you're tuning in from Ontario, it would be probably what you've seen from about grade 9 to about grade 12 calculus and vectors. And then if you're tuning in from the US, we're looking from basically pre-algebra all the way to pre-calculus. Again, my name is Joey. I'm currently an Ontario school educator with OneClass, and my subjects of interest are chemistry and mathematics, and I'll be able to walk through and verify these solutions for you as well. So we have some frequently asked problems. We have some solutions given to us by students and teachers all over the world, and my goal is to verify those solutions and explain the concepts behind those questions so that you have the best solutions moving forward in either future courses or assignments or some tests and whatnot. So without further ado, let's get started on today's problems. I have about 10 problems that we can work on today, and we'll be able to verify those solutions. So let's get started. All right, our first problem here is asking us what are the values of a, b, c in the quadratic equation negative 2x squared plus 4x minus 3 equals 0, where a, b, c are the coefficients of x squared, x to the power of 1, and x to the power of 0, respectively. So I have here, so here's question 1, and we have this quadratic equation. We have negative 2x squared plus 4x minus 3 equals 0. And what they want to know is we want to know what the ABC are, where we want to know the values of ABC in the quadratic equation based off the coefficients of x squared, x to the power of 1, and x to the power of 0. So what we can do here is we can actually generalize our quadratic equation, and a general form of our quadratic equation is the following. So we have ax squared plus bx plus c equals 0, and this here is the format for our general equation. So we have some type of second degree term here plus some type of first degree term here, and then you can call this a constant term, or you can actually say that this is x to the power of 0. Because if you think about this problem in terms of a, b, and c, and in terms of these coefficients here, we can actually rewrite this guy into, this is going to equal also ax squared plus bx also to the power of 1, and in this case, because x here is also x to the power of 1, right? So I'm just rewriting this here. In c here, you can think of it as multiplying by x to the power of 0, and we know that anything to the power of 0 is simply just 1, right? So it doesn't change our c value here. It's still constant, and this term also equals this term as well. And again, this x to the power of 0 equals 1, so this does not affect the constant term here. So now all we have to do is look at our quadratic equation that's given to us and see what terms fit in this guy here. So again, we have negative 2 beside x squared, so which means a here has to equal negative 2. We have 4x here besides, we have 4 here for b, according to this template here, because we have the x value here, or we can think of it as x to the power of 1, and then we have our b value here. So it's going to have to be a positive 4. So this b here will equal 4. And finally, c here is going to have to equal negative 3, because that's going to be our constant term. And we don't see the x to the power of 0 because x to the power of 0 is simply just 1. But we can say here c is going to equal this negative 3 term here. So a, b, c are these coefficients here, negative 2, 4, and negative 2, a equals negative 2, b equals positive 4, and c here equals negative 3. So this here is our solution, which is the correct solution. So this solution is correct. Sweet. That's number 1. Number 2, what is 10 to the 5th power? So we have here, so we want, what is 10 to the 5th power? And what we have here is some type of exponent. So you would probably see exponent laws in grade 9 or about pre-algebra or algebra 1. And what this is asking us, it's asking us what is 10 to the power or to the 5th power. So according to our exponents, what we have here is we have some type of base value, and then we have some type of exponent value here. And in this case here, we have 10 to the 5th power. So it means 10 here is going to be our base value. So let me do that in a different color. 10 here is going to be our base value. And then it's going to be to the 5th power. So to the 5th power is going to be our exponents here. So we have 5th power here, exponents is the power of 5, right? So this will be to the power of 5. And this here is going to be our exponent, or base and our exponent for this problem here. So now we have to solve this 10 to the power of 5, right? So what does this mean? Well, 10 to the power of 5 can also be written as the base times the number of times the exponent happens, right? So we have this here, our base here, which is 10. And then we're going to multiply that by 10 5 times by also 10. So it's going to be 10 times 10 times 10 times 10 times 10. And this here is our exponent rewritten as in terms of multiplication here. And we learned this in kind of our exponent laws in pre-algebra here. And what we can do now is we can solve this problem, right? What we can say here is we can say that 10 times 10 here is 100 times 10 times 10 times 10. So these two make 100 here. Again, 100 times 10 here makes 1,000 times 10 times 10. 1,000 times 10 is 10,000 times 10. And then finally 10,000 times 10 here is going to equal 100,000. Oh, that's a million. 100,000 here. So this is going to be our solution. So therefore, we can write that 10 to the power of 5 is going to equal 100,000. And this here is our solution. And as you can see, this solution is also correct because 10 to the power of 5 equals 100,000. So the solution is good. Good analysis. Okay, let's go. So the solution here is correct. All right, let's look at number 3. It's asking us the vertex angle of an isosceles triangle measures 40 degrees. What is the measure of a base triangle? So we have, so I like this, like looking at this first half of our solution, I liked it. I like what they're doing already because they have some type of diagram. And with geometry problems, and again, you see this problem probably in a geometry class, or you would see this in a grade 9, maybe introduction to trigonometry kind of unit type of problem. So this here is a great approach to looking at this problem. So we actually want to draw a diagram to help us figure this out. So what we can do here is, I'm going to actually copy their diagram here because it's the correct diagram. So what we have is the vertex angle of an isosceles triangle. So the vertex here angle would be this angle A, because our isosceles triangle means that two sides are the same, right? So remember, so note that in an isosceles triangle, oh, that's not how you spell triangle. We have two sides are the same. Two side lengths are the same. So we denote these guys with a small dash, right? So this here means that these two sides are the same, and the vertex angle of these isosceles triangles, or where these isosceles sides meet in the vertex of the angle, would be here, right? Because it meets at this angle here. So this angle would be 40 degrees. And this is exactly the same diagram we have here. So this is correct. So we have an isosceles triangle where two side lengths are the same, and it's asking us what is the measure of a base angle. So we want to figure out, when this is in blue, what is these angles here. And we usually denote this in theta or some type of Greek letter to figure out what the angle is of the base, or what is the measure of the base angle here. So this problem really breaks down into our understanding, or the fundamental understanding of our triangles, of our isosceles triangle, our equilateral triangle. You can have something like acute angles and obtuse angles as well, and triangles as well. And what we have to know to solve this problem, the giveaway here is this triangle being in an isosceles triangle. If we know that two side lengths are the same, we know that their angles must also be the same, due to the theorem where you have side angle or side. And those theorems in geometry help us prove that whether something is congruent or similar or whatnot. So in this case here, an isosceles triangle, I can say if two side lengths are the same, then their angles must also be the same. So that means we know that this angle B here, and angle C are going to be equal to each other. So we're solving for the same angle here, and they're going to be the same value here. And if we know this piece of information, then the problem is very, very easy, right? We know that in a triangle, with the sum of the interior triangles in a triangle, the sum of the interior triangles of a triangle is going to be 180 degrees, right? So we can say that sum of interior angles in triangle equals 180 degrees, right? So therefore, we can say that 180 degrees is going to equal our vertex angle, which is 40 degrees, plus this angle here and this angle here, right? And we know these guys are the same. So we can say angle theta plus theta plus theta. And we know that thetas are the same, right? So we can collect like terms. You can also visualize this as any type of variable you want. You can visualize this as x or whatnot. So you can say 180 degrees would equal 40 degrees plus 2 theta. Because again, you can collect these like terms, right? And what we can easily do now, we can easily solve for this theta here using algebra, right? So you can move 40 degrees to the other side and isolate theta here. So I can subtract 40 from both sides here. So I would get 180 minus 40, which is going to be 140 degrees. It's going to equal 2 theta. And then finally, I can divide both sides by 2, right? So theta here is going to equal 140 degrees divided by 2, which will equal 70 degrees. So therefore, we can say that this angle here is going to be 70 degrees. And this angle here is also equal 70 degrees. And you can make sure that they add up to 180 degrees, right? 70 degrees plus 70 degrees is 140, plus 40 degrees here is 180. So this here is our solution for this problem. So you can say, therefore, base angle equals 70 degrees. And this here is our solution for this problem. So let's check the solution. So it says, since ABC is an isosceles triangle in which side AB is equal to AC, this implies that angle B equals angle C. So this is the correct, they use the correct theorem here. And again, you simply just have to isolate for that theta. And I chose using theta, they chose using angle B, which is totally fine. And this here is going to equal 70 degrees. So this solution here is correct. So that was number 3. Okay, number 4 here is asking us, how do you find the square root of 81? The square root of 81. So what we can do here is we can, there's basically, again, 2 ways of thinking about this problem. You can use either prime factorization, or you can use kind of a trial and error in this case here. And the only reason why we can use trial and error here is because we know that 81 here is a perfect square, and we know that through trial and error. So let me walk you through this problem using trial and error first, and then I'll do another method that involves taking the prime factors of 81 here. So trial and error, basically, what we want to know is if we want to know the square root of 81, so this here is we can write this mathematically using the square root term and putting 81 inside the square root term. So this here is square root of 81. And what we can do here, we know that the inverse of the square root is equal to simply the exponent squared, right? So what we can do here is we can actually write out our exponents, right? We can use trial and error, and we can see which exponents would equal this term here. So let's start off with 1 squared. So I know that 1 squared here is equal to 1 times 1, which is 1. 2 squared is 2 times 2, which is equal to 4, or 2 squared is equal to 4. 3 squared is 3 times 3, which equals 9. 4 squared is 16. 4 times 4 is 16. 5 squared is 5 times 5, which is 25. 6 squared is 6 times 6, which equals 36. And I'll move on to the side. 7 squared here is 49, because 7 times 7 is 49. 8 squared here is, and we're looking for 81 here, right? 8 squared here is 8 times 8, which is 64. And 9 squared here is 9 times 9, which equals 81. So this here is our magic number here, 81, right? So if we know 9 squared is equal to 81, what we can do is if I want to square root both sides, I can get rid of this exponent, right? So I can take the square root of this side and the square root of this side. So these guys cancel out. So the square root and the exponent here cancels out, so which means 9 would equal the square root of 81. So this here would be our solution. The square root of 81 would equal 9 based off trial and error. So this here could be our solution due to trial and error. But what we can do is, if we did not know that this here was a perfect square, and sometimes it's not a perfect square, and it's not as nice to us, what we can do here is we can use prime factorization to solve for this problem here. So let me scroll down and say that if we had, again, square root of 81 as our problem here, what we can do is we can actually take the factors of 81 to see if we can solve for this solution here. And what we usually do this when we don't have a perfect square, because it helps us write our radicals in a simplified radical term where we have a constant and we have some type of radical. So what we can do here is we can look at 81, and we can break root 81 down into its prime factors. So this is going to equal, we have to think of numbers that are divisible by into 81. What goes into 81 here? And upon first kind of inspection here, we can safely say that 2 is not divisible into 81, or it's not a factor of 81, because it's not an even number. So we would move on from 2 to 3, and we can say, is 3 a factor of 81? Well, in this case, yes, it is a factor of 81, because what we can a cheat to, or a quick way to know factors of if something can go is divisible by 3 is simply adding up the digits inside the number here and seeing if that in itself is divisible by 3. So 8 plus 1 here is 9, and 9 here is divisible by 3, because 3 times 3 is 9. So therefore we can say that 3 here is a factor of 81. So let's pull out a 3 here, or root 3 here, and we're going to divide 81 by 3 here. So let's do some side work here. So 81 divided by 3. So we're going to have 27 as our remainder, right? So, or sorry, as a quotient here. So it's 3 times 27 is going to equal 81 here. And what we can do here is we can actually repeat this step, right? Well, we can break 27 down into more components, right? So we can say 81 would equal, or I'm just going to actually write the equal sign, root 3 times, and 27 here, I know that this is divisible by 3 because 3 times 9 is 27, right? So I can pull out another 3 here, and then this would be 3 times 9 is equal to 27, right? And now this problem is very, very easy. You should be able to see that root 9 here is simply just 3. So what we can do here is we can say that root 3 times root 3 times the square root of 9 is simply just 3, right? Because I know that 3 times 3 is equal to 9. So I can say this is multiplied by 3. And finally, I can combine these guys here, right? Root 3 times root 3 is going to also equal root 9. Because I'm simply multiplying the whatever is in the square root times 3. And the root 9 is obviously, like we said before, we know that root 9 here equals 3, right? So we can say this is simply just 3 times 3, which is going to equal 9, which means the square root of 81 is going to equal 9 in this solution here. So either way, both of these guys will give us the answer for this problem. One is obviously quicker because it's trial and error. One takes a little bit longer, but it really depends if you're very familiar with your perfect squares or not. So this solution here is correct because we have square root of 81 is 9. But if we want to be a little bit more formal here, we can say that the square root of 81 here is actually plus or minus 9. Because again, 9 times 9 here is going to equal 81, but also negative 9 times negative 9 will also equal 81 here. So you have to also, if we're looking at, from this problem from a quadratic kind of point of view here, both answers are suitable. So plus or minus 9 are suitable answers for this problem. So this solution here is correct. They have 9 here, so it's plus or minus 9, which is the correct solution. Next problem is another square root problem. So this is question 5. It's asking us, how do you find the square root of 25? So what we can do is we can do the exact same type of method as we did with our previous question. What we can do is we can use trial and error, and we can take the prime factors. So either way works, right? In this case, I would actually just use the prime factors because 25 is a relatively low number for a square root. So in this case here, I would just use trial and error, and you would be able to solve this problem very, very easily. I won't go in depth as in terms of the previous question, like in the previous question, doing two methods. I'm just going to use a trial method, an error method to solve for 25, because I know for a fact that 25 is a perfect square, because 25 here, any number that's ending in 5 is divisible by 5, and 5 times 5 is equal to 25, which means that I know that the square root of 25 is going to equal 5. So let's write this out first. So I have square root of 25. And again, I can use my trial and error method, right? So you have 1 squared equals 1 times 1, which is 1. 2 squared is 2 times 2, which equals 4. 3 squared is 9. 4 squared is 16. And 5 squared, 5 times 5, is going to equal 25. And this here is our solution, because 5 squared equals 25. I can take the square root of both sides here, and these guys will cancel out, which means 5 has to equal the square root of 25, which means the solution is going to be 5. So this here is our solution for this problem. Square root of 25 is going to equal 5. If we want to be technical here, we can say square root of 25 is going to equal plus or minus 5, because again, 5 times 5 is equal to 25, but negative 5 times negative 5 is also equal to 25. So technically, square root of 25 is equal to plus or minus 25. So this here is our solution, and again, this solution here is correct. All right, so number 6 here. So number 6 is asking us, how do you factor x cubed plus 27? So let's look at this problem here. So we have, this is question 6. We want to factor x cubed plus 27. So how do you factor this? Well, what we can see here, like upon first expansion, you can think of this as there's only 2 terms here, and having 2 terms is not the greatest thing sometimes, because how do we usually approach factoring? Well, we approach factoring using 2 types of kind of approaches here. We can use a decomposition method where we break down usually a third, the second term in a trinomial and then we break it down into two different terms to see if we can find some common factoring. We can approach this using simply common factoring, but as you can see, x cubed and 27 do not have like terms, right? So you can't common factor here. And we can also approach this using kind of factoring by inspection. So I don't see that the product of two numbers is going to equal something that can be summed. So in this case here, these don't apply. However, whenever we have two terms in a kind of a factoring question, you can think of this problem as either a difference of squares problem, or in more advancedly, in this case here, we have the sum or difference of cubes question. And the reason why we can think of this as that is because of this giveaway here. This exponent 3 means that we don't have a difference of squares, because difference of squares would have the power of 2. So we have the sum or difference of cubes here. And the cubes here is going to give us the giveaway, because our exponent is to the power of 3. In this case, we have the sum of cubes, right? Because again, this here is an addition sign here. So that's another giveaway. So therefore, we have something called the sum of cubes. And this here is a special type of, we use a special type of formula to factor sum of cubes here. And let me write this out for you. So sum of cubes, I have some type of a cubed, or x cubed in this case, plus b cubed is going to equal, and b cubed would be this term here. And what we can do is we can actually check that this here is a difference of cubes because of this term here. 27 here, if I cube root this 27, I know that cube root of 27 is going to equal 3. Or, yes, it's going to equal 3 here. Because 3 times 3 times 3 is equal to 27. So let me write on the side here. The cube root of 27 is equal to 3. So therefore, the sum of cubes, we can use this and get a very, very nice equation here. So back to the formula, we have a cubed plus b cubed is going to equal a plus b times a squared minus a b plus b squared. And this here is going to be our formula for the sum of cubes. Now what we can do here, we can use this formula to solve for this guy here, right? Well, we have x cubed plus 27, right? So what is this going to equal? Well, this is going to first equal a plus b here. And a plus b here is simply just the cubed root of these guys here. So if I cube root x here, let's do an aside here. If I cube root x here, well, I cubed root 27 already, which is going to equal 3. And let me do this in a different color, because this is some aside stuff here. Let me do this in yellow here. So let me see. So the cube root, sorry, I don't know why my pen is like this. Just working before, oh, I'm on the eraser. That's fine. Okay, so if I have the cubed root of x here, of x cubed, well, simply the cubed root and the x is going to cancel out, right? So if cubed root here is simply just equal x. And if we have the cubed root of 27, well, I told you that it was 3 times 3 times 3, so this will equal simply just 3, right? Which means that a here is simply this term here, so it's simply just this term, the cube root of this term, which is simply just equals to x. And then we have b here, which is the cube root of b, so cube root of 27, I said it was positive 3 here, so this is going to be x plus 3 times a squared. So a now here is the first term, so we have x here is our first term, which is a, well it's a squared, it's simply just x squared, right? So this is x squared minus AB. So what's AB here? I know it's x and 3 here, which is a and b, right? Because we wrote x and 3 here. So I can say a times b here is 3x. Oh, sorry. And then we have b squared here, which is simply just this term squared, right? So we have b, if b here equals 3, then b squared is going to equal 9, right? Because 3 times 3 here equals 9. So we have this guy here. And this will be our factoring for this problem, right? So this here is x plus 3 and x squared minus 3x plus 9. And this here is our solution for this problem. How do you factor this? Well, we factor it using the sum of cubes. And this here is our problem. Usually this trinomial, you could try to actually factor this out here, but usually, and I say usually, this trinomial is not factorable after the sum of cubes. So that is going to be how you finish this problem. Because this, again, you can try to factor this, but this isn't factorable. You can check this by simply taking a times c here, which is 1 times 9, which is 1 9, and no product of 9 is going to sum into -3 here. So we can visually say that this here is going to be unfactorable. So this here will be the factored problem of x cubed plus 27. And as you can see, this solution is correct because you have x plus 3 and x squared minus 3x plus 9. So this solution here is correct. Good analysis. All right, that's number 6. Number 7. What is the first step in solving 5 minus 2x is less than 8x minus 3? So 5 minus 2x less than 8x minus 3. So we want to solve here. So what we can do here is we can, this is here simply just an inequality type of problem here. And we solve inequalities basically by using kind of the same method as equality, but with one type of solution. Well, one type of exception here. Every time you divide, so let me write this out here. Inequalities behave like equalities, or the equal sign, except when, so when we divide by a negative number, to both sides, we flip the inequality. So let's say when we're doing some algebra here, we're going to divide by, let's say, -2 here or something like that to both sides. If we divide by -2 to both sides, we're going to flip the inequality. So instead of less than, this would become greater than if we do divide by a negative number. And there's only one exception to this inequality here. So if we do recognize that we have to divide by a negative number to solve for a problem, then we flip the sign. So let's treat this as a equality then. So we have 5 minus 2x is less than 8x minus 3. So what we can do is let's organize the like terms, right? We have 5 and 3 here that we can organize, and we have -2 and 8x, right? So let's move 5 to the other side. So we're going to add 5 to, we're going to subtract 5 from both sides here. So we get -2x is less than 8x, and we're going to subtract 5 from both sides. So this here will be -3 minus 5, which is going to equal -8. And then what we can do here is we can actually move 8x to this side as well, right? To solve for our, to collect like terms. So we can subtract both sides by -8x. And -2x minus 8x here is going to equal -10x, right? And now what we can do here is we can, we have -10 here. We can divide both sides by -10. So this is going to equal, x here is going to equal, and again, this here is when my exception happens, right? This here is, again, I'm dividing by a negative number, I'm dividing by -10. So this here meets my exception here. Inequalities behave like equalities, the equal sign, except when dividing by a negative number to both sides, we flip the inequality. And again, in this case here, we're dividing by -10, which is a negative number. So therefore, we're going to flip this less than into a greater than sign. So we're going to flip the sign when we divide by -10, and we do the same thing with our equalities here, right? And then we do algebra. So we have -8 divided by -10. These guys cancel out. So I have 8 over 10. And again, I can reduce this, right? I can reduce this fraction. X is greater than 8 over 10. I can reduce this into 4 over 5. Because again, I can divide by 2 and divide by 2. And this would equal 4 over 5. 8 divided by 2 is 4. 10 divided by 2 here is 5. So therefore, we have x is greater than 4 over 5. And this here is our solution. And as you can see, this solution here is correct. They wrote it the other way, but this is 4 over 5 is less than x, or you can say x is greater than 4 over 5. So this here is our solution. And in this, they even graphed it nicely as well. And when you have x's, I guess this is 4/5, then this here is all the values are greater than 4 over 5. So this solution here is correct. All right, so that's number 7. Number 8. I think the question got cut off here, but it's asking us, let's see. I think it's 1.6 here. Yeah, 1.6 as a fraction. So converting from decimals to fractions here. So what we can do here is, well, 1.6 as a fraction, we have some type of decimal into a fraction, right? So we have some type of decimal, and we want to change it to a fraction. Well, if I have 1.6 here, what I can do is I can change this into a mixed fraction first before I change this into an improper or a proper fraction, right? So I have 1.6 here, and this here is my whole part, and this here is going to be my fraction part, right? So this is going to equal 1, which is going to have the whole part here, and 6 here is going to be the my fraction part. And as you can see, this 6 here lies in the tens digit of a decimal. So therefore, if it lies in the series in the tens digit, I can say that the denominator here is going to be 10, and the numerator is whatever in our the decimal place here, which is going to equal 6. So this is 1 6/10 here. And what we can do is we can take two approaches now. We can either convert this into an improper fraction, or we can reduce. It doesn't really tell us what to do in terms of, do we want a mixed fraction or improper fraction? But in this case here, I'm just going to convert into an improper fraction and reduce. You can either reduce or convert into improper, or you can convert into improper first and reduce. It doesn't really matter for the order here as well. But I'm going to convert into an improper first. So how do we do that? How do we convert this into an improper fraction? Well, I'm going to multiply the whole part by the denominator. So 1 times 10, and we get add to the numerator here. So 1 times 10, and again, this denominator is still 10. So 1 times 10 here is 10 plus 6 here, which is going to equal 16. And again, now I can reduce, right? 16 and 10 here. I know that 2 is factorable in these two guys here. So I can divide this by 2 and divide this by 2. I'm going to get 8 over 5. 16 divided by 2 is 8. 10 divided by 2 here is going to equal 5, which means this here is our solution. 8 over 5 is our solution. So 1.6. So let's say therefore 1.6 is 8 over 5 as a fraction. And this here is our solution, which is good because the 1.6 is 8 over 5 as a fraction. So this solution here is correct. Let's do 2 more problems for today. So we have question 9 and question 10 left. So it says, given the triangle XYZ, calculate the value of sine x. So again, with all geometry problems, I like to draw a diagram. This here is x, this here is y, this here is z. And this is nice because this is here is a right triangle. It says here this is 3 units, and this side here is 5 units. And what we want to do is find the value of sine x here. And this here, I guess, is our small x. So I'll say this here is angle x here. And we want to calculate the value of sine x. So what we can do first is let's use our trigonometric ratios, and let's see if we can actually just immediately solve for it, right? So usually I use a mnemonic called the SOHCAHTOA. So SOHCAHTOA, and what this is it's a mnemonic for some primary trig ratios, right? So S here is going to be sine is equal to opposite over the hypotenuse. cosine is adjacent over hypotenuse, and tangent here is opposite over adjacent. In this case here, we care about sine, right? So this here is sine is going to equal the opposite side over the hypotenuse. And we want sine of x here. So if we look at here, sine x here is going to equal opposite of hypotenuse. Well, the opposite side is, well, I'm not given this side, right? This side is unknown. I'm going to say that this here is equal to the side yz is, or yz is unknown, right? So this here is going to be yz over the hypotenuse, which is given to us as 5. So we now have written a this is sine x. We've now written an algebraic expression to solve for sine x here. But again, we're missing some type of information because we're not given our angle here, and we're not given our yz here, right? So what we have to do is solve for yz. And how do we do that? Well, we can use the Pythagorean theorem to solve for yz, because this here is we have a right triangle, and this here we have two sides, which means we can algebraically solve for the third side here. So let's say that I'm going to say that for the sake of Pythagorean theorem, I'm going to use xz squared is equal to xy squared plus yz squared. And this here is what we're looking for, because yz squared is the side we're looking for. Well, we know that xz is equal to 5, right? So this here is 5 squared is equal to, well, I know xy, also the length of xy is equal to 3, right? So we can say that this is also equal to 3, and then we square the value. This is y squared. So we have 5 squared is equal to 25, is equal to 3 squared, which is 3 times 3, which is equal to 9, plus yz squared. And then I can algebraically isolate for yz squared, right? So we can say that we can minus sign from both sides to get 25 minus 9, which is going to equal 16, is yz squared. And then we can square root both sides to solve for this problem, right? So I would have the square root of 16 is equal to square root of yz squared. These two guys cancel out. So yz is going to be equal to the square root of 16, which is going to equal 4. And in this case here, it's technically root of 16 is equal to plus or minus 4, but in this case here, a negative value would not make sense, right? Because how do you get a negative length in our triangle? So what we can do is we can actually say that because negative 4 is not a valid length, we use positive 4. So in this case here, we neglect this value and say that this is only equal to 4. So yz then is equal to 4, which means I can solve for sine x, right? So the ratio of sine x here is sine x is equal to, again, hypotenuse, opposite of hypotenuse, which is yz over hypotenuse, which is 5. And we know that yz is equal to 4. So we can say that sine x is going to equal 4 over 5. And this here is our solution. So therefore, I can say that sine x is going to equal 4 over 5. And this here is our solution for this problem. So again, as you can see, sine x is equal yz over xz, which is the hypotenuse. I wrote this as a hypotenuse, which is fine. But it's, again, the same value, right? 4 over 5 is the required value. So the solution here is correct. I like what they did here as well, because yz is equal to 4 units, since distance cannot be negative, right? So I said since negative 4 is not a valid length, because you can't have a valid length, therefore you only take the 4 value, the positive value here. So the solution here is correct. All right, and finally, let's look at question 10. So it's asking us, how do you write 3/5 as a percent? 3 over 5. Maybe I'll use a little bit lighter color here. 5 as a percent. So what we can do here is, what do we have here? Well, we have 3 over 5, which is some type of fraction. And we want to convert this into a percent. So how do we convert fractions into percent? Well, we simply, this arrow here, this process is simply just multiplying by 100%, right? So what we have here is we have 3 over 5. I can multiply this by 100% to get us our percentage value here. So we have 3/5. What we can do here is 3/5 times multiply by 100%. Well, what I can do first is I can simply divide 100 by 5 here, right? So okay, I can take out this 5 here, and then I can also do 100 divided by 5, which is going to equal 20. So therefore, we have simply just operation 3 times 20. We know 3 times 20 is going to equal 60. And this will be our percent for our question here. So we can say, therefore, 3 over 5 is 60%. And as you can see, this solution here is correct because they did, you convert 3/5 to percentage form. So 3 over 5 by 100, and 3/5 times 100 is equal to 60%. So this solution here is correct. All right, that's going to be the last question for the day. Again, thank you so much for watching this stream. Again, my name is Joey. I stream basically twice a week because I'm a little bit busier now. I stream on Monday mornings, and I stream on Wednesday mornings. Mondays are typically my math sessions in high school math, and Wednesdays are typically my chemistry sessions, and also in high school and university level chemistry as well. Again, my name is Joey. If you like these videos, again, definitely check out our OneClass live stream. You can access this at oneclass.com/livestream, or you can access this on any of our other live streaming software. I believe we're on YouTube, so we can subscribe to our YouTube channel at youtube.com/OneClass, and you can follow us to get notifications when I go live or when the other tutors go live as well. Again, my name is Joey. Thank you so much for watching this stream. Stay safe, stay healthy, and have a great day. Take care.